Here's our examples from 8th grade Mod 4, Lesson 13. Can the following points be on the graph of the equation 2x minus y equals 9? Explain. And they give us this graph, and the graph has some points on it. So what you're going to do is first start by picking a point on the graph. So let's pick a point. I'm going to pick the point 5, 1. Let me highlight that point for you on the graph. Here's point 5, 1. Again, to get that point, you just go straight down. You land on 5. Go across to the y-axis, and you get 1. So your x value is 5, your y value is 1. Okay, so from here what you're going to do is take that point and you're going to substitute the x value in for the x in the equation and the y value in for the y into the equation we're given. So you're going to substitute 5 in for the x and 1 in for the y. So let's take a look at what happens when we do that. So again, we're substituting into the equation, and we're going to check to see if it's a solution to the equation. So our equation was 2x minus y equals 9. Substitute the 5 in for the x and the 1 in for the 9. So we'd have 2 times 5 minus 1 equals 9. From here you have to calculate the left-hand side. So I'm looking at the left-hand side. I'm going to calculate that. 2 times 5 minus 1. And 2 times 5 is 10. 10 minus 1 is 9. And 9 does equal 9. So this is a true equation. So that tells us, since it's a true equation, the point 5, 1 is a solution to the equation. At this point, though, you have to check one other point. These points are all in a straight line. Since they're all in a straight line, pick one second point. Any point you want. We're going to pick the point 6, 3. Let me highlight that so you see where 6, 3 came from. 6, 3 is this point up here. So again, how did I got that point? I went straight down below it to get the x value is 6. And then I went across to the y-axis, and I got a y value of 3. So you're going to do the same thing we did before. You're going to substitute that point into the equation and check to see if it's a solution. So let's do that. So I have 2 times x minus y equals 9. And I'm going to plug in the 6 for the x and the 3 for the y. 2 times 6 is 12. So 12 minus 3 is 9. So we get 9 equals 9. So it's a true equation. So that means 6, 3 is a solution to the equation. So let's answer our question. Can the following points be on the graph of the equation 2x minus y equals 9? So here's what we could say. Yes, because each point on the graph represents a solution to the linear equation 2x minus y equals 9. And also note here, the points do appear to form a straight line. Let's look at one other example. So can the following points be on the graph of the equation x minus y equals 1? Explain. So this example, if you notice, the points do not all fall in a straight line like the previous example did. So if they do fall in a straight line, it's sufficient to check 2 points. If they don't, it is sufficient to check 1 point if you end up getting it's not a solution. Okay, so let's go through and check this. I'm going to pick a point. I'm using the point -2, -1. So where I got that point from, right here. Again, go to the x-axis, and you land on -2. And then go across to the y, and you land on -1. So the x value is -2, the y is -1. So we're going to use the same procedure. We're going to substitute that point into the equation and check to see if it's a solution. So let's go through and begin. I'm going to write my equation down, x minus y equals 1. Plug in -2 for x, -1 for y. So -2 minus a -1. So we have to calculate this left-hand side to see if we get a positive 1. So that double negative changes to a positive 1, so -2 plus 1 gives us -1. So this is a false equation, so therefore we know -2, -1 is not a solution to the equation. So therefore we know, since one of those points is not a solution, this is not the graph of this equation. So let's state the following. No, because the graph contains the point -2, -1, which is not a solution to the equation x minus y equals 1. And then also please note here, the points are not in a line. Okay, so this is not even a linear equation, or the graph is not a linear equation. It does not represent one because the points do not fall in a straight line. Also note, if you're watching this video, we did not use slope-intercept form or use graphing methods because we did not learn those yet, according to where we're at in our module.